In this particular module, we're going to look into the various statistical methods which form the foundation for any machine learning algorithm. So what are the things that we're going to look into in this particular module? We have descriptive statistics, we have probability and conditional probability, we have the various probability distributions. We concentrate on the main three, that is binomial, Poisson, and normal. And last but not the least, we have inferential statistics. So what is statistics? This is a practice or science of collecting and analyzing numerical data in large quantities, especially for the purpose of inferring proportions in whole from those in a representative sample. Well, it's obviously a big bounce. So let's look at the more simpler definition that we all understand. So basically, it's a branch of science that deals with numerical data. It is mainly used to infer knowledge about big sections, or we can call them parts or proportions, by trying to understand a smaller section of that bigger chunk. So basically, the concept of population and sample come in here. So a population is considered the entire data. So if you want to say, if you want to talk about an example, or let's take an example to understand this better, we can say that all the people in a particular state can be called as the population and be referred as the population for our particular experiment of whatever purpose we are taking that population into consideration. So a sample would be a part of that particular population. So if you say that, okay, so there are a few states in a particular country and I want 10 to 20 people from each and every state. So basically what you're doing is you're taking samples from those populations, or you can say the entire country is a population here and you're taking various samples from various places, which in turn will represent the entire population. We're going to look into details and you'll understand this better as and when we come across various factors. So why do we need statistics? And I know that you already got that, but let's just have a look at it. So the major reason is that it helps us understand data better. So if we understand the data better, we are going to work on it better. When I say we are going to work on it better, basically what we are trying to say is that we're using various statistical tools and methods to understand the data better, or you know, we are using particular tools and techniques to come up with some outcome, come up with some understanding. Correct. That brings us to our next point. When we work on it better, our deliverables or outcomes after working on the data turns out to be better. It's as simple as that. And all of this is possible just because our statistical methods help us to understand the data better. Kinds of data do we deal with? So I've been tossing around this word data for quite some time now, but I haven't explained it in detail. So the first thing you need to understand is that data can be structured or unstructured. When I talk about unstructured data, it's basically something that is way more complex to see, visualize, and understand. An audio file will have various wavelength. It has various channels. If I have to say it in a way, there is mono and there is stereo, and there are various other factors which make it difficult to just look at and understand. Whereas, in the other hand, we have structured data, which is in the tabular form where there are columns and rows, which makes it very easy for us to understand just by having a look at it. The best example for any structured data would be an Excel sheet. And I'm hoping that everybody here at least has seen an Excel sheet, if not have worked. Well, the entire data over there is just represented in columns and rows, which makes it really, really easy to understand. Now, there are other divisions of data as well. The singular form of data is called datum. Many people do not know that. Even I did not know that for a couple of years. Yeah, so the main two divisions that data can have is numerical and categorical. So when I say, okay, how many legs do you have? You say two. How many hands do you have? Two. How many eyes do you have? Two. How many nose do you have? You have one. So basically, all these numbers or anything, any data that you can represent in a numeric format comes under this particular category. But when we say about categorical data or quantitative data, basically we are talking about something that is more of textual. What do I mean by that? So when I say, okay, what's your gender? You either say a boy or a girl. You do not say 0 or 1. Correct. So that's how categorical data is different from numerical data. Numerical data is also called as quantitative data. Now, the higher divisions, we'll look into them one by one. Let's look into the numerical aspect first. So we have discrete data and we have continuous. So the major difference between them that makes it different is that discrete data concentrates more on whole numbers. How many children do you have? Two. How many how many people do you have in your family? Three or four, whatever number that is. So it's basically it deals with whole numbers, but when we come to continuous data, it basically deals with decimals. So when I say what is the balance, what is the current balance for your savings account, you will say okay, it's somewhere around 12,000 50.6 paise or 60 paise or 70 paise or 60 paise if you have to put it that way. Or you'll say that, okay, what is your height? My height is 155.55 centimeters. It's not always necessary that your height will be 155. Or if your height is 154.99, it is not equivalent to 155. You're rounding it off, which obviously tells you why we need two different types of numerical data. Correct. Let's move on to categorical data. So we have binomial data, we have nominal or unordered data, and we have ordinal data. Well, the words might sound really, really confusing, but to be honest, they're really simple. So let's look at binomial data. So the word bi means two here, and any particular outcome which has only, sorry, what I mean is any particular answer or solution which only has two probable outcomes makes it come under this particular category. So when I say if I toss a coin, what's going to be the outcome? It's either going to be heads, it's going to be tails. Correct. That's how it comes under binomial. So let's look into nominal. So nominal is where the categories come into play, but they are not in an orderly format or you cannot rank them. So when I say, okay, how many t-shirts do you have? Or what are the, so you'll say three, and what are the colors? So you go on to say, okay, I have red, green, and blue. So if I ask you to order it, the very next question that you will have is, okay, so how do I order it? You red is not higher in power or higher in hierarchy than blue. So how do I order it? That's where ordinal data comes into play. Well, you're not going to order it by color, but there'll be some ways of ordering it, correct? So if you want to see in any clothing brand, when you go to visit in the mall or any particular shop, they always order their particular clothing in an ascending order, where you have the smallest size first, and then it goes on to the largest size that is possible for that particular brand or that particular clothing. So you see what I'm trying to point out here, right? So ordinal data is basically data that you can rank. When I say that who are the top three scorers from a particular match, you say, okay, there is player one who scored the highest and is the best. Then there's player two who scored good, better than three, but not as good as one. So he's in the second position. Now, when you say, okay, so the third player did better than the rest, but not as good as player two and one, so he's in the third rank. So you order them, you can order them. That's ordinal. We understood nominal and binary. So that's what you need to know about the data and its various types.